What is estimation? Well, there's no way you can sample the entire population. The only thing you can do is get a sample of it. From that sample, hopefully the sample's large enough because we've decided what our outcome is going to be. We can generate an estimate of how much power or how much sample size we're going to need to detect that difference. Go out and sample it. Generate parameters from that. What's a parameter?
Guideline or a rule.
A parameter of a model.
So like
Parameter.
what alpha rate you're willing to accept?
That's one of them. The mean, standard error, those are parameters that come and play a role in defining the model. Okay. And then an estimation, once you get the model, if it's right, which is a big if sometimes, but large enough sample size, do you guys remember the central limit theorem from statistics? Central limit theorem. What is that? Basically, the central limit theorem says no matter what you start with, if you get a large enough sample size with repeated sampling, you're going to get a normal distribution. Ultimately, everything will collapse to a normal bell-shaped curve with enough sample. Your sample may not be large enough to do that. So you might have to use an alternate distribution like a chi-square distribution or like an F distribution or a Pareto distribution. There are many different types of distributions. A T distribution. Ultimately, with enough sample size in the correct model, they will converge to being a normal. The normal allows you to make generalizations about the larger population, right? The larger population, for more or less, is going to be normal. So if your sample has the same distribution as the population, your sample is a good sample and allows you to make estimation on that population now. Hence the crystal ball kind of feeling. Statistics allows you to get a feeling for what the general population would have.